So I just inserted this slide from last year because I think a lot of you who weren't here and a lot of you have questions about what's the relationship between Apptainer and Singularity and all that. So just to quickly go through a brief history of where we came from. So Singularity 2, the first widely used one was first written in C in 2015. And there were lots of people contributing to that, and then this was getting very popular. It also this is before the days of unprivileged user namespaces, but then when RHEL 7 came along, later release of RHEL 7, where they started to support that, then that got added. And our community, the high throughput community that we work with at Fermilab, a lot of high energy physics especially, had already started using the user namespace mode back then in Singularity 2. But then Greg founded Scilabs, and there they completely rewrote Singularity and Singularity 3, rewritten in Go, lots and lots of new features. And then a few years later, Greg left Scilabs. Scilabs continued on, but he left, and he took the ownership of the Singularity project he took with him, and along with a couple of the core developers. And then he decided, okay, instead of being hosted in this new company, he created a new community organization called HPCNG, which was not very well known. It never did get very big. And then a year later, Scilabs decided to fork the project, and so they created another one called Singularity CE, those who were left in Scilabs. And so now we were in this really confusing situation. There's two open source projects with very similar names, run by different groups. So about 6 months later, Singularity joined the Linux Foundation, and they required a name change. They say we can't trademark the Singularity name, especially because there's the other one, Singularity CE. There will be contention over it, so that's how we got a new name. So Apptainer is the continuation of the Singularity project, but it had to change the name. And then instead of Greg just being the owner, he became just one of 5 leaders in the technical steering committee, and I'm on that committee. So then first release came out in March, so 4 years ago now the first Apptainer release came out. And then that fall, the rootless by default is kind of the major innovation of Apptainer. All right, so now what's happened since last year? So there's been several point releases of 1.4, and mostly bug fixes, and then last week we finally had the 1.5.0 release candidate. And so yeah, they're all bug fixes. There was one minor security issue with an option that's not used much called -- security. And overall, Apptainer's been quite stable, and not many people asking for major new features, and there are some in 1.5.0, so I'll get into that. So the first one is Ping-Fei was asking about. CDI is kind of the major new one. This is a container device interface. It's a standard from the Cloud Native Computing Foundation, and for describing. So for container runtimes to use to describe new hardware devices that you want to include inside the container. So it's actually the way it's defined. It's a JSON file. It's intended to be just to kind of apply this to the OCI specification for a container. And Apptainer, we don't use that. We're able to read OCI containers and convert them, but we don't use them internally. So instead, Apptainer, the new feature support, just looks inside it for 3 important pieces of information. One is /dev devices to import to bind into the container. Now by default, Apptainer already binds everything in /dev. So By default, it doesn't actually have to do anything for this, except when you're using the -contain option, and then it only supports imports selected /devs, or there's also an equivalent apptainer.conf configuration to do the same thing. So otherwise, it also lists bind mounts from files in the host. So that would be like for those kinds of things that --nv does to pull in libraries from the host, and or environment variables. So those are the three major categories that in a CDI specification. And so now you just there's a new option called --device. You pass up the name of the file, this JSON file that describes the CDI of this hardware. Then and you can also give it directories to search for those files with the --CDI editors. And separately, before we got the CDI in, somebody from Intel contributed a change for one new hardware device, their Gaudi accelerators. And we decided to just leave that in, make it a little simpler for people. They don't have to have the CDI. In fact, when I tried to test this, I tried to find the CDI. They said, yeah, we have CDI descriptions of this. Tried to find the CDI description of a Gaudi. Well, it required layers upon layers of dependencies in order to compile a tool that will generate it, and I ended up giving up on that, so I didn't actually end up. So I said, let's just leave. It's actually quite a simple option for just to import the /dev files when needed. So, okay. So other new kind of significant features in 1.5.0 is an option to directly build a CIF file from a Docker file. It looks like it's actually indirect, but it looks like it's one step. You say, you can, I think it's an option. Oh, no, I know, it's a bootstrap. So it's a bootstrap in the definition file that says bootstrap from a Docker file, and then it will call out to build kit. So that's a whole separate package, right? So if you have that installed and configured on your machine, then Apptainer can just use it to compile from the Docker file and convert it to CIF directly, so it's a little simpler. Users don't have to run the commands themselves. And it does require setting up the etc sub-UID mapping, which Apptainer itself doesn't require for building a CIF file, so that might be an extra requirement. I don't know if people will want to do that or not, but it could be a convenience for people. In addition, there's support for using IPFS. This is a type of distribution system for peer-to-peer clustering, IPFS. So you can it can use a IPFS gateway, HTTP gateway that got added as I think it's also a bootstrap. No, I think it's a URL in the command line. You use IPFS:// to access a CIF file to download. And another new feature is support for completely reducible CIF images, meaning that they'll have the exact same bytes. Before, every time you build a new one, it would have a new date stamp in it. So if you set this source date epoch, which is kind of used by other tools as well, it will just use that same date stamp each time. And or you can, if you use --reproducible and you're downloaded with ORS, then it will just use the date that's stored with the file in ORS. Another feature is just recording the original OCI image. So if you start from OCI image, it will store that also in the CIF metadata, again for reproducibility. And also just printing the hash when pulling from or pushing to the ORS. Okay, and then this also, it can preserve the owner and group of files, even when running a building unprivileged. So, when you're running unprivileged, you only got one user ID. So it's really, I'm not talking just unprivileged, but even in the fake root command line mode, where it's really only, it doesn't even have the sub-UID and sub-GID mapping. What it does is it takes advantage of the fact that the library that downloads these OCI containers, like from Docker Hub, they store the original owner and group in extended attributes, which any unprivileged user can create. And so then what we do is when the make squash FS step is done by Apptainer when it's building a CIF file, we just wrap that with a proot, a modified proot command from the same project, the rootless containers project. And then it converts those extended attributes into, make it look like they're actually there on the file. So if you do an ls, then they're, that shows those owner and group. So that way it gets put into the squash FS partition that gets put into CIF. If you don't want that, there's a new option that can turn that off. And then when squashing is needed, like for example, if you build on top of a local CIF file image, it has to unsquash it first, work on it, and then squash it back. Then and that's another new feature, is that it will make sure that it doesn't try to run as root as a pseudo root, like a fake root, when it runs the unsquash FS. Okay, then some more minor things. There's a new, by default, Apptainer imports all environment variables if you don't tell it not to. So this, now you can tell it, import everything except these few variables, which I know are causing problems. And that was a request from a user. And also another request was to be able to build a data CIF file. So there was already a way to do that with several commands, several Apptainer CIF commands. You could go and create a CIF file with just a data partition, not with code in it. And so this is just a convenience that you can directly take a squash FS partition and create a CIF file out of it with the -- data option. And another new feature is there's to work especially with the systemd resolved feature tool, where what it does is it creates an etcresolve.conf that is a symlink to elsewhere, and that file changes. So system, like it might be useful for like a laptop where you're moving around from network to network and you want to have a different DNS that shows up. This feature now is by default, if it sees etcresolve.conf as a symlink, it just makes a symlink inside the container as well and bind mounts the original, so that way, or actually the directory of the original, so that you can notice updated resolve.conf. Or if you want, you can just tell it, if you want to maintain it yourself, you can tell it to not mount etcresolve.conf. That wasn't an option before. Another new feature is the ability to go to the beginning or add something to the beginning or end of LD library path. Now this is relevant to the discussion we were having before, that the --NV can have a problem with glibc, right? Importing from the host into the container. So what this does now is it uses this new feature and appends the to the LD library path, the imported libraries. Okay, so the imported libraries it goes into a directory /.singularity.d/libs. So instead of putting it at the beginning, so what this means is that if the container has its own copies of those same libraries, those will take precedence. So you can, if you have a problem with importing the host libraries, you can put them into the container instead. And it also usually it's a problem. It was that usually LD library path is inferred by glibc systems. You don't set LD library path, but it looks in the system, runs, and has configured ones in your operating system. So this will be, if LD library path is not set and it's a glibc based one, it will look them up with LD config and set LD library path. So that way you can append to it. Otherwise, before, it was the only way to do it was to put it at the beginning. So, okay, and then the only other things, minor things, is the default ARM variant. I guess hardly any older ARM CPUs are still out there, so we decided to upgrade that. Default ARM variant used, and also when using ORS, it used to just kind of assume it was AMD 64, but now it looks at the host's architecture, and we'll try and match that, or you can specify which architecture you want to push and pull. So, questions about this or about anything? Those are the only talks we had. Nobody else volunteered. All of you guys are here, but you didn't volunteer to give a talk yourself. But we're open for any kind of discussion that people want to talk about. Any questions you have about Apptainer and related things.
So is it on?
Yep.
Okay. So I seem to recall that the default way to get access to CVMFS is to rely on the host to provide you access and then bind mounting. Is there any reason that you couldn't also have it directly inside the Apptainer image, or is it that it's not a full system, right? It's just an executable with the glibc stack, right?
Right. You can use CVMFS exec, but the standard CVMFS package, it makes some assumptions about multiple user IDs, root and the CVMFS user, and those generally don't hold inside the Apptainer container. So that's why. But yeah, you can use CVMFS exec inside of an image. In fact, the OSG provides containers that do that. By default, you just pass in options to the container when you mount it, and it'll mount the CVMFS inside the container. Mm-hmm.
I'm sorry. I'm actually going to ask one quick question, and then unfortunately I've got to run. Mm-hmm. So I will ask a question, and then I'll just give you the mic.
You got 15 more minutes yet.
Well, but my Uber's coming at 3, so I have to get out there. So could you talk a little bit more? You were talking about some of the files that are necessary in order to use the new device mapping capabilities within Apptainer. Can you talk a little bit more about, is there a place to obtain those files, or do you have to generate those files, or how do you get those files?
Yeah, presumably the vendor of the device is supposed to provide them. Okay, so this is because these files will work with Docker and Podman already. So if they want to be able to support, that's usually what happens, right? Is people they want to support Docker and Podman, then we should be able to take that same file and apply it to Apptainer as well.
Is there a central repository or?
I don't know about a central repository, but there's default directories like etc/cdi, so it's the default place to look for it, things like that, or var run cdi, those two directories.
Cool, thanks.
So I'm wondering, is that on the roadmap about maybe beta test or testing feature using ROFS instead of SquashFS, ROFS?
Rephrase that. So what was that again?
Right. So I know Podman and some other container runtime might be they're testing ROFS as an alternative to SquashFS.
Oh, what's it called again?
ERO.
ROFS?
Yeah.
Yeah, I hadn't heard of that.
It's a relatively new thing, and only the latest kernel supports that.
The kernel does support it? It does not?
It does.
It does?
Yeah, latest.
Okay. Well, All right, as far as the kernels, and it does a better job of compressing, is that the thing?
Yeah.
Okay, well, first of all, it was already, I think in 1.4.0, I don't, or either that or it's one of the 1.4x's, I should look at last year's talk. It was a 1.4.0 that we added better compression options to so SquashFS already does work on lots of different compression options. Those were already added. So Apptainer, and there you can specify lots of different compression options, the things that you want to put into the CIF file. So that's one thing about it. The other is that it's actually security risk to use the kernel. Okay, so Apptainer, we don't even use the SquashFS kernel module anymore. We did with, the kernel doesn't allow user namespaces to use SquashFS, but Apptainer used to do it through setuid root mode, right? So we would say, but we're setuid root, we can do what we want. But yet the kernel was not happy, was the kernel developers didn't trust letting user namespaces use the SquashFS, or it doesn't. The only thing it allows is fuse, right? So basically, the only driver it allows is fuse. I mean, there's also overlayFS, right? So kind of overlayFS and fuse are the only two that the kernel developers felt was safe enough to allow user namespaces to use, unprivileged user namespaces. So even if there is another kernel module that's better, we'd have to see the fuse alternatives in order to be able to include it.
Yep.
Yeah, and now I had done a lot of measurements with Squash Fuse LL. So the Squash, in my measurements, it's just as good as the kernel for read-only. So as far as performance goes, so very parallelized and all that. And so yeah, at least for the benchmarks I was using, it was just as good as the kernel as far as performance. So.
Yeah.
Anybody else?
I have a very general question in terms of generally we use HPC for very much optimized software packages that is built for that CPU architecture and all those things. But when we start using containers, people just start downloading from Docker Hub, anything garbage, whatever they get, and they. So how much efficiency we lose when we go by? Means those packages are not built those are for DevOps packages. Just they are built for run on any architecture.
So you're wondering about optimized compiles for particular architectures, right? So I kind of figured that's something outside of Apptainer that you need to deal with, right? So certainly you could distribute a different container that's optimized for each target. It's a matter of then figuring out how to. That's more like something for the binaries working group in HPSF. You figure out Apptainer. That's a higher level problem. But yeah, certainly it doesn't have to. You don't have to use the default, portable one from Docker Hub. And Docker Hub can also have optimized ones if you wanted to, but yeah. Mm-hmm.
I think there was a general solution to that, and that they were fine mounting something on CVMFS that would then pick the directory based on the host's architecture. So if it was x86 64 v4, it would for the binaries where it mattered, it would mount the correct one. Mm-hmm. And I think it was using SPAC and optimized binaries and different CVMFS directories.
If you have CVMFS, which I highly endorse,
Yeah.
Yeah, you can, it's pretty cheap to put in multiple copies, and you can also tell it to, either with a shell script or using there's a CVFS feature to be able to select different things based on the local configuration.
So I will also share anecdotally that our software was compiled to SSE3 because that was the lowest common denominator for some really old AMD CPUs that we were using on the global grid. We had some countries that were contributing very, very old hardware. Right, when our distributed computing grid was, single node PCs up to cluster size at a university or something, and so we had to optimize to the lowest common denominator.
Yeah, that's what we do in high throughput computing. Says we figure there's all sorts of different hardware architectures that we run on. We usually just go to the lowest common denominator and not optimize it, but it doesn't have to be that way. Go ahead.
Thank you. So my question is about the build kit. I think that's really interesting that you can build without definition files and use Docker files. So does that have to be solely Docker files, or you still need some definition file at all? That's one. Then the second part. So with Apptainer installation, you can go without set UID, set GID mappings.
Right.
And that would still be fine. But I think I saw with the build kit, you said it does need.
Yes, because it's based on like the same tool set as Podman, right? And Podman, it's only well, certainly when you're doing building of packages, there's a lot of times you're installing something that's expected to have multiple user IDs, and so even when Apptainer builds a CIF file, it uses some sort of fake root. Right, so either it uses the etc sub-UID sub-GD mapping, which actually works more often, or it has an option where it can just use the fake root command and insert that in there, and that works a lot of the time, but not all the time. But the build kit doesn't have that feature. So if you are building, from what we call a singularity file, definition file, Apptainer definition file, then you don't necessarily need etc sub-UID sub-GID mapping, which is a little hassle for system administrators to set up. But if you're using build kit, you do need that. Yeah. So just like if you had Podman, you're doing the Podman build command. Yeah. Anybody have other things they wanted to discuss? See, I think we had, yeah, go ahead.
Is it? Oh, yeah. Do you have any? This is because I don't know how it works, but are you able to debug or using debugging tools within Apptainer? How does it work? Do you have to have anything installed in the host, plus anything additional within the container, or how does it work?
I mean, you could have GDB inside the container
Right.
You can run in there. I've sometimes had things like, I want to use strace. It's not in the container. Okay, I'll just bind mount it in from the host, assuming it's got a compatible host, inside the container and outside that. And sometimes you need to bind mount extra libraries or something that it might be depending on too. But yeah, you can use that bind anything you can run unprivileged.
Yeah, I was also thinking more in parallel debuggers like GDB for HPC or tools like HPC Toolkit.
I don't know if that's. It's all run. Probably you can. The one thing that I often try to remind people is that Apptainer is not really. It's not designed to emulate a whole operating system. So if you've got something that needs to be listening on multiple ports or something, or needs it's not designed to emulate the whole operating system like Docker does, right? Docker kind of tries to be a virtual machine, tries to be almost a virtual machine without duplicating the kernel, right? Apptainer doesn't try to do that much. It tries to be a way of installing software while still keeping your original environment as much as possible, right? So sometimes some of those complicated things, they just don't work well. But I don't know about that particular one. If it's just a simple user-based application, it might just work fine. Yeah.
Well, it's served well with the GLab CI solution for our SL7 images, right?
Yeah. Yeah.
Yeah. Fermilab's dirty laundry that is it off?
Got turned off.
Well, you can probably hear me. Hello?
Yeah.
So it's part of our dirty laundry that we had to move off of SL7, but we couldn't move off of SL7. So we moved all the hosts off of SL7 and run everything in an SL.
And because we didn't have to, because we had containers. So,
Yes, we had containers, and it provides a GLab CI solution.
so it's a
what it
lot
really
easier,
provides.
for people to just keep using it. Yeah. Yeah. Anything else? I think we had listed a long time for discussion because it just didn't have any other talk, so you don't have to use them all. So. Oh, is there coffee now? Okay. All right.